Hello, this video will be covering polynomial division. We'll talk about polynomial long division, synthetic division, and remainder theorem. Right now on the screen, I'm providing a list of steps with an example that goes side by side with them for polynomial long division. If you had to choose a method, I would recommend learning polynomial long division because that works for all cases. But it is useful to know the other two ways. So let's start with our classic long division problem that you might have seen in an elementary school math classroom. There are 8 students that want to share 18 cookies. How many cookies can each student have? So we know we're dividing 18 by 8. Whoops. So you set up that long division problem. Let's discuss some vocab so it makes it easier to discuss when we're doing our polynomial long division. You know what you're dividing by is called the divisor. What you are dividing from is called the dividend. The answer that we're going to get is going to be called the quotient, right? And then anything that's remaining will be called the remainder. So (18 divided by 8). 8 goes into 1 0 times. That's a leading 0, so you don't have to write it. 8 goes into 18 twice. So 2 times 8 is 16. Subtract that from 18, you get 2. So each student could have 2 whole cookies, right? Your quotient is 2. With 2 cookies remaining, this is your remainder. But what if the students had, let's say they had a butter knife and they were able to split the cookies? You would be splitting that remainder amongst the 8 people. So you would be splitting those 2 cookies left over by the 8 students. You always divide your remainder by the divisor. And if we wanted to simplify, we know that's 2 plus 1/4. So that means that each student could have 2 cookies and 1/4 of a cookie. What about how many cookies can a student have if there were 16 cookies? Now this might seem like an easier problem with numbers, but I tend to see with polynomial long division, when students get 0, they get a little confused what to do with that 0. So 8 goes into 16. 2 times 8, 16. Subtract that, you get 0. The remainder is 0. You don't have to do anything with the remainder, but if you want to split that 0 amongst the 8, we know that that's still going to be 0. So each student would just get 2 cookies. Also notice this. 8 is a divisor of 16, so the remainder is 0. 8 is not a divisor, is not a factor of 18, so it actually has a remainder. Okay, so let's graduate from elementary school math, and we're going to move to polynomial long division. So, the first step, set up as a typical long division problem. So look at that. That's your setup right there. They set up that typical long division problem. So then it says divide the first term of your dividend by the first term of your divisor. So what's 3x squared divided by x? 3x. The next step, multiply both terms in the dividend by the first term of the quotient. should say, of the divisor. So 3x times x, 3x squared, 3x times 6, 18x. We're going to subtract that from your 3x squared plus 20x. You end up getting 2x. You bring down the 28. X goes, now we repeat the step. So x goes into 2x, 2 times. 2 times x, 2x, 2 times 6, 12. You subtract that, you end up getting 16, and look at that. 16 is your remainder. Remember, you always put the remainder over the divisor. Okay. So let's do our own problem now. Set up that typical long division problem. X plus 4 goes into 8x squared plus 37x plus 41. X goes into 8x squared, 8x times, multiply that out now, so 8x times x, 8x squared, 8x times 4, 32x. Subtract that whole term. If you're subtracting that entire term, you have to put parentheses around it. Or switch the signs. The first term should always cancel out. And then 37x minus 32x would be 5x. Bring down the 41. X goes into 5x, 5 times. X times 5, 5x. 4 times 5, 20. Subtract. First term always cancels out. 41 minus 20 is 21. You put your remainder over the divisor. That's your answer. That's quotient remainder form. Now let's do synthetic division. Notice that this is the same problem, so we should get the same answer. First step of synthetic division. Set your divisor equal to 0 and solve. Something that's important to note, synthetic division only works if the divisor has a leading coefficient of 1 and a leading term with a degree 1. So, you set the divisor equal to 0, you solve, you take that number, make a big L next to it, and then you're going to put all the coefficients and constants in the order that they're written. If there's a term missing, which we'll go more into depth about in the next synthetic division problem, then you're going to have to put a placeholder 0. You always bring down the first term, multiply, negative 4 times negative 8, negative 32, add that, what you end up getting, 5, negative 4 times 5, negative 20, add that, 21. You are dividing x squared by x. So it's going to be 1 less x, right? You divide it out in x. So it's rather than starting with a square, it's going to start with the linear term. So we have 8x plus 5 plus the last term is always your remainder. So 21 over your divisor, which was x plus 4. Let's check that we got the same answer as we did with polynomial long. Look at that, we did. So now, the same problem, but we're going to use remainder theorem. So the remainder theorem, it's not going to give you the quotient, but it will give you the remainder, so you could see if it's divisible, or if what you're dividing by is a factor, or is a divisor. All different ways of wording the same problem. So you do exactly what you did with synthetic. You set your divisor equal to 0 and solve. And then plug into the equation you're dividing from, the dividend. So 8 times negative 4 to the second power plus 37 times negative 4 plus 41. Put that in your calculator. You end up getting 21. Let's see if we could see where 21 is in our answer. Oh, look at that. 21 was the remainder, hence why it's called the remainder theorem. You set your divisor equal to 0 and plug into the dividend. What you end up getting is the remainder. So, if there's a remainder, right, if it doesn't equal 0, so there is a remainder, that means that x plus 4, or your divisor, is not a divisor, or is not a factor of the equation you're dividing from, or your dividend. So it's not a perfect factor. Doesn't go into it evenly. Okay, we have a new problem, and it wants us to do all three methods that we just learned. So first, let's do a remainder theorem, just because that's the quickest. We have remainder theorem. You set your divisor equal to 0, solve, plug in. And by the way, it would be excellent if, you do one way, and then you check using the remainder theorem. Because let's say you're trying to find the quotient. If you have a different remainder than what the remainder theorem gives you, then something's wrong, and you could check your work. So 10 times negative 5 to the third minus 9 times negative 5 squared plus 6. We ended up getting negative 1,469. Does that equal 0? No. So if you have a remainder that's not 0, that means that it is not a divisor. So we know that x plus 5 is either not a divisor or not a factor of 10x to the third minus 9x squared plus 6. Okay? So that's remainder theorem. Now let's do polynomial long division. Set up your typical long division problem. Okay? And look at that. You have your cubic term, or your third degree term. You have your quadratic term, or your second degree term. You have your constant term, which, if you imagine it having an x, it would be to the 0th power, because x to the 0 is 1. So that's 0th degree. Are we missing a term? It looks like we're missing our linear term, or our degree 1 term. So we have to put a placeholder 0 for our degree 1 term. And now we just have to do our polynomial long division like usual. X goes into 10x to the third, 10x squared times x, 10x to the third, 5 times 10x squared, 50x squared. Subtract the entire thing, so put parentheses or switch both signs. First term cancels out. We get negative 59x squared. Bring down that 0x term. X goes into negative 59x squared, negative 59x times. Multiply that, so negative 59x times x, negative 59x squared, 5 times negative 59x. You get negative 295x. Subtract, the sign switched, so you would get 295x. Bring down that 6. X goes into 295x, 295 times. X times 295, 295x. 5 times 295, 1,475. Subtract that entire term, and you end up getting negative 1,469. Look at that. You got the same remainder as you did with the remainder theorem. You always put the remainder over the divisor. So that's your answer. That's your quotient. quotient remainder form. Okay? So that's polynomial long division. And now synthetic division. You basically do what you did here with the remainder theorem. You take, whoops, bad color. Synthetic division. You take your divisor, set it equal to 0, solve, rewrite that number, put a big L there, line up the coefficients and constants in the order that they're written, but we're missing a term. We have our cubic term, we have our quadratic term, we have our constant term, we're missing our linear term. So you're going to put a placeholder 0 where the linear term should be. You bring down the first term, multiply, so you get negative 50, add negative 59, multiply negative 5 times negative 59, 295, add, you get 295, negative 5 times 295, negative 1,475, add, and you get negative 1,469. This started as a cubic and you're dividing out x, right? So it's going to be 1 less x. So it's going to be x squared. 10x squared minus 59x plus 295 minus 1,469 over the divisor, x plus 5. We got the same answer. Okay, now for 2 region questions. Which binomial is not a factor of the expression? So you could do polynomial long division, you could do synthetic division, but that's a lot of work when you have 4 things that you have to check. So what you could do is use the remainder theorem. Set them equal to 0 and solve. In this case, it would be x equals negative 2, x equals negative 4, x equals positive 6, x equals positive 7, and then you just have to plug in. So negative 2 to the third minus 11 times negative 2 squared plus 16 times negative 2 plus 84. Negative 4 to the third minus 11 times negative 4 squared plus 16 times negative 4 plus 84. 6 to the third minus 11 times 6 squared plus 16 times 6 plus 84. 7 to the third minus 11 times 7 to the second plus 16 times 7 plus 84. Put that in your calculator. You could put that in exactly as it is, or if you want to be quick on it, put the function into your y equals. So x to the third minus 11x squared plus 16x plus 84. I'm going to graph it, second trace, value, and then you could input whatever value you want. Or something that's even easier because these are all integers. Just go to your table, second graph. Negative 2. You would end up getting 0. So that's a factor because it doesn't have a remainder. For 2, so negative 4, you get negative 220. It does have a remainder, so that means it is not a factor. So that should be your answer. But let's check that I typed it in right. X minus 6, so where x equals 6, you get 0. And for x equals 7, you get 0. So all of these were factors. There was only one that was not a factor. Okay? And then lastly, this is another region question, and the reason I'm throwing this in here isn't because it's so much work, but typically students will know the steps to polynomial long division, but they don't really think of it as a graphed function, right? So I don't see any really definite points. You're not going to be able to do a regression or a line of best fit. But let's think about this equation. There's a 0 at -4. There's a 0 at 0. There's a 0 at 3. And you know by 0, I mean either root or x-intercept. All right. So we know one of the factors of this equation is x plus 4, which we could already answer this, right? But I'm not going to tell you until after. 0, x minus 0, x plus 0 would just be x, right? 3 is going to be x minus 3. And we also don't know the leading coefficient, so I'm just going to put a. If you had a point on the function, which we do have points, but I don't see any definite points, what you could do is you could plug in and solve for the leading coefficient if you had to. But it's a lot of work and it's not asking that. So it says, what is the remainder when p of x is divided by x plus 4? Well, is this equation divisible by x plus 4? Yes. So if it's divisible, then you know the remainder is 0. Right? You just have to kind of logically think about that. Okay. So hopefully this helped. Yeah. Have a great night, everyone.